As we begin our study of mathematical explorations, we're going to start with a topic called set theory. We experience sets all the time, and sets are all around us, but we don't always formalize these ideas so that you can get a grasp of the concept of sets. And so in this opening section, we're going to look at some definitions and some examples of sets and the different ways they can be constructed so that you can more quickly categorize the things around you into sets and separate things off. It just gives you more clarity as you study other topics. We'll be utilizing sets in the study of logic, in the study of probability and statistics, and these things are really more general. They encompass, sets encompass studying many different topics throughout your education, throughout your careers, and just in life in general. And so having the ability in your mind to separate off sets and give definitions to sets is going to be very valuable. Okay, so the first thing we're going to look at here is just a general definition of sets. A set is a collection of objects whose contents can be clearly determined. Okay, so it's a collection of things. Like, for instance, the collection of students taking this class is a set. Okay, it's a very specific set with very specific elements within the set. The objects in the set are called elements. Okay, so we'll talk about elements being part of a set. And if the elements can be clearly determined, that means they're very well defined and you can determine every single one of them very clearly. The set is called well defined. Okay, so for instance, the set of all students in this class is very well defined. I can print out my roster and look at the individual people, and that constitutes the set of people or students taking this class. All right, the set of greatest basketball players is not well defined. The top 10 greatest basketball players, for instance, because every list will be slightly different, and it really depends upon how you determine the word greatest. All right, so those are some ideas or examples of things that are well defined and are not well defined. Sets can be collection of people. They can be collections of anything. They can be collections of numbers. They could be collections of diseases or plants. But any collection of elements that has a well-defined description is considered a set. Okay. Now sets can be constructed in really two different ways, or notated in two different ways. We call them the roster notation and the set builder notation. So roster and the set builder. Now the roster notation is really just where you list off the elements of the set. It's the most straightforward, maybe easy to understand and comprehend, but it can be more clunky, especially for larger sets. All right, for instance, the set of all digits, for instance. The digits are zeros. The digits are numbers 0 through 9, right? And so the set of all digits would just be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That would be the roster notation for the set of digits, which isn't too bad, right? You can just list off the 9 digits. In set builder notation, this might be a little bit more complicated. You might say something, so set builder notation really gives you two parts. There's a way to symbolize the element and then a way to describe the element. Okay, for instance, in set builder notation, you might have the symbol that you want to use. Let's say digits, we use the letter D to symbolize digits, right? I don't know, I'm just making this up as I go. Then we separate with a vertical bar to separate the elements of the set, or the symbol for the elements, with the actual description of the elements. The description of the elements here in this case would be, well, these are natural numbers. I'm sorry, no, they're whole numbers because they include the number 0. They're whole numbers less than 10. So I might write out some description here that's well defined. You can easily identify every number in that set. So they are whole numbers. I'll say D is a whole number less than 10. Or you could say maybe a single digit whole number. There's a variety of ways you could define that. So it doesn't have to be a particular way to define it, but it has to be equivalent, okay? So there's other things you could say there, but as long as you can very well define or very specifically define every number in that set, then you have a well-defined set. So we have the roster notation, the set builder. Now the roster, again, this is where you list, it's a list of all elements. The set builder notation gives two parts again. The first part is the symbol for the set, or the symbol for the elements, followed by the description. Okay, some sort of description, a symbol and then a description for that symbol.